Let's see how to compute the confidence interval. In just previous lectures, we have seen what is confidence interval. Okay, now let's see. Just if we have a distribution, suppose let's take we have a distributions x, and we know its distribution. Suppose let's take we know its distribution. Suppose let's take it's a normally distributed function. Suppose let's take it's a normally distributed and normally distributed, and as well we know its mean and its standard deviations. Suppose let's take as regular, suppose let's take the random variable x is height of the student, each heights of the student, and we know its mean and its standard deviation. We know its mean and its standard deviation. Suppose let's it mean is equals to 168 centimeter. Suppose let and its standard deviations for the distribution, suppose let its standard deviation is 5 centimeters. Suppose let actually this is not a original data. Suppose let this for this lecture, let's take these examples. Okay, so if we know this data, then we can easily plot this type of curve for these distributions. So if this is x, then we can easily plot this kind of curve. Okay, this is the mu of these distributions. This is the simple mu of these distributions. And suppose let's take this is the first standard deviations. This is the second standard deviations, means 2 sigma, and let's take it's the third standard deviation, 3 sigma. Similarly for here as well, sigma, 2 sigma, sigma. Let's take third standard deviation, 3 sigma. Now in one of our previous lectures, we have seen if a Gaussian distributions follows, if a Gaussian distribution, it follows the 95, 68, 95, 68, 95, 99 rule. If you forget, please go there and you can easily find it. So 60 means that in the range of first standard deviations, we have 68% of the data in this range. In the range of the first standard deviations, we have 68% of the data. And in the range of second standard deviations, in the range of the second standard deviations, we have 95% of the data. In the range of second standard deviations, we have 95% of the data. And in the range of 3 standard deviations, we have 99% of the data. We have 99% of the data. This formula is talking about this thing. We have already seen this thing. Means what? If this is 65% and 95%, means these regions mean what? And these regions means actually this is the 95. Total up to here we have taken the 95%, and these regions will be how much? 2.5. Means I am talking about these regions after 2 sigma. Means this total whole these regions. This 2.5%. Suppose like that, you will calculate it yourself. Okay, this formula is taking. Now the questions is mu minus, in the range of the mu minus 2 sigma to mu plus 2 sigma. If you in the range of the mu minus sigma to 2 sigma, we have 95% of the observations. We have 95% of my observation. Okay, we have seen this thing. Means what is actually mu here is 160, means just write this thing for our better understanding. What is mu? Mu is simple 168. First sigma is what? Means if this is mu, means what? This, if this is mu plus actually, these things is mu plus, everything is mu plus, mu plus. This is also mu plus. This is also mu plus. Mu plus this range, mu plus this range, mu plus. Sorry, mu minus here in that side, in left side mu minus. It will be mu minus. Mu minus. This side also mu minus. Sure. Mu plus sigma means what? This range will be 165 plus 5 means 173. 173. 173 plus 5 means what? 178. 175 plus 5 means what? 183. Okay. Mu minus 5. Mu minus 5 means 168 minus 5, 163 centimeter. 163 minus 5 means 158 centimeter, and 158 minus 5 means 153 centimeter. That's the range actually for every. Now what it means actually, this range, or what is it talking about? This range are actually talking about in the, actually this is will be the third, this range in that. This range are talking about in the range of minus 2 sigma to mu plus 2 sigma, means this range in the this interval 153 to 178, 158, sorry, 158 to 178, mean in the range of the two standard deviations. In that range we have 95%. In this 95% data, means on observations, just in the state, instead of using observations I am taking the data. Just now this means what? This thing means what actually? Actually these things means our mu means what? Mu means our population mean. Here this mu means what? This mu means population mean. This mu means population mean, means our population mean lie on the interval. How much confidence? With 95% confidence. This means the population mean mu lie on the interval 158 to 178 interval, lie on this interval with 95% confidence. With 95% confidence. Okay, these things are actually meaning about. Okay, I think you have understand, means on that range, on the range of the mu minus 2 sigma to mu plus 2 sigma, we have 95% confident that our mu will be lie on this range. These things are actually. Now let's say if we have the sigma, if we have the normal distributions, then from this rule we can easily conclude that. But if we don't know, suppose let's redraw this picture again. I think then it is better for us. Suppose let's take, it's our distribution, and we interest to find, instead of taking, suppose here it is, we have known that 68%, 95, 99 rule, but suppose let's take we don't know node, and we suppose let's take we are find such a different type of confidence. Okay, suppose let's take we have interest to find the confidence, and suppose 90%. Suppose let's take we are find to such kind of answer we want to get. Means what will be the interval? What will be the interval with, suppose let's, with 90% confidence? with 90% confidence. What will be the interval? Would suppose let's take with 80% confidence. What will be the interval with 70% confidence? Okay, if we want to find this kind of answer, if we know that for Gaussian distributions this formula are hold, then we can easily find the interval for 68, 95, 99. But if we don't know what will be the this range for 90% confidence, what will be the range for the 80%, what will be this range for 70%, we don't know anything about this thing. So now in that situations, how we will find this interval range? Now let's see. Suppose let's take the area of the distributions. Suppose let's take the area of these distributions. This is the sample mu range. This is the sample mu hour. Suppose let's take on this the area on that range. Suppose let's take this area is C. This area is C. So if this is the C, then what will be the area of these portions? Just lie on just see the green portions. What will be the area on this green portion? Means total area is 1. Okay, total area is 1. If this is C, the rest of the area is 1 minus C. Total means this total green portion area is 1 minus C, and we have divided the green portions symmetrically. So now these portions will be 1 minus C by 2. Similarly, these portions will be 1 minus C by 2. Now we are interested to find this interval, in which interval this is a lie. So what will be the interval? What will be? What will be this value of the which if it is Gaussian distributions, we can easily find. So what will be the mu minus delta? What will be the mu plus delta? What is actually this delta value? So what is this? Now what is this value of this delta? What is the value of delta? This is the question. That's answer we are interested to find. If we got this answer, then for these normal distributions we can easily find any kind of confidence interval. So that's answer. So for this rule, here we know if C is equals to 95%, if C is equals to 95%, then this interval will be 1 minus 95% means 2.5% interval will be 2.5. Okay, for this from this formula we can find, but for 95, for 99, 80, for 70, how will this find? Let's see. Now to get this answer, if they are have one table, corresponding table, the table is called the normal distribution table. If you search it on Google or any probability statistics book, just you can easily find this table. Logarithmic table, normal distribution table, tree distribution table, they are everything, every tables are easily available. Just search it on Google, you can easily find. So in previous dates, there have no any such kind of complex computational power. In those dates, the scientists, the mathematicians are use these tables to find the value of this. What will be this value for this interval? So to find this answer, they have the normal distribution table. So let's see how these tables are actually used to compute this interval value. Let's see this thing. Suppose let's take this the axis and the corresponding distribution for the corresponding distribution for this is equals to like that. Suppose let's take this the mu. This is the mu means mean, and this is the corresponding. We are finding the value of this, means we are finding the value of the 90%. So let's take, we are finding the interval in 90% confidence interval. What with the 90% confidence? Yeah, means if this area is 90%, if this area is 90%, means if this area is 90%, then what should be this value? Suppose let's take this value, left value is x dash, right value is x double dash. Suppose let's take now from this range we can conclude that our mean, we can from this thing we can conclude that the population mean, we can conclude that the population mean mu lie on the range, lie in the range x dash to x double dash with 90% confidence, with 90% with 90% confidence. Okay, and if you see the normal distribution, I think it will be better if you just see just I will seeing you from a Google. Just go to the Google page, then from there I will see you. Now let's see. This is the standard normal distribution table, standard normal table that I have taken from the Google image. Okay, already we have learned how to convert a normal distribution to a standard normal distribution. Already we have learned these things, one of our previous lecture. Suppose let's take we have a distribution x that follows the normal distributions in with mu and sigma, and if you just convert these distributions, to a normal distribution, extract, suppose let's take it is the normal distributions, with normal means with mu will be 0 and standard deviations will be 1. So how will this doing these jobs? So now x means I'm talking about x, small x will be equals to x dashed minus mu by sigma. Okay, this is the simple that doing, means where x dashed belongs to our capital and x dashed random variable, and small x will belongs to this random variable. This x will be, it belongs to this random variable. So these jobs already we have seen these things. By simple using this formula, we can convert any normal distributions to a standard normal distribution. This is any normal distribution. This is simple any normal distribution, and this formula is called the standard normal distribution. Standard normal distributions. By using this formula, we can easily transform any normal distribution to a standard normal distribution. I think you got that. Now, by simple, if you just convert these things to a standard normal distribution, and then this mean will be now 0, and the standard deviations for the distributions now will be 1. By simple, after converting these things, we can easily from this table, from the standard normal table, we can easily find this value of the x and x dash. Now let's see how we will find this value from these tables. Suppose let's take from these examples, we will find the confidence interval 90% confidence interval. Means what? We will interest to find the value. Suppose let's take this is the mean. This is the mean is equals to 0. Just to zoom it little bit. I think this then these things will be better for me. Okay, this is the simple mu, and if this is mu, we are finding the 90% area. means in both side we will suppose it's different, means in both side we will find the area, in both side we will find the area that's occupy the 90% area, the 90% area that's occupy the 90% area, that's we interest to find 90% area. If both sides are occupied the 90%, suppose let's take this value we are interested to find, this value is x test and this side value is, let's take x double dash, means it calls the lower limit, these things call the lower limit, and this side call the upper limit of this distance of our confidence interval, upper limit of our confidence interval. These are the upper limit, this is the lower limit. Now what will be the value of this x dash and x? So if the whole portions are 90%, then what will be the area of the is these half portions? So now the value of these half portions will be 45%. Now we have to, from these tables, this area is actually talking about these regions from mean to this range. Okay, now first we have to find the value, means what, where the 45%. If you convert this 45% to the normal value, means between the 0 and 1, so what should be the value of the between 0 and 1? This value will be 0.45. now we have to find in our table what should be the value 0.45. so let's see, so the 45% means 0.45 value will be lie on that range here, lie on here 0.45 is like, means approximate, not accurately 0.45%, mean approximately 40%. Just now let's see the thing, now let's see in which value these things are. Just say this thing, this one 0.16. okay, first thing that I have observed. Now let's try to understand what is actually this thing. And in the, if you just see this thing in above portion, what should be the this one? Now this value is 0.5. okay, these two value we have interested. Now for the 40% area, this thing, these two things are for this telling us the z value, means this is the z, means I am talking about the x test, I'm talking about this x test, this x test means z, means this x test means small test I am talking about. Okay, after converting, so z to z, its mean is mu and sigma, its mean is 0 and standard deviation is 1. This is standardized, I am standardized z to the x to the z. So now what is actually this thing? Let's see. So now the thing is this is the x 1.6 and 0.6. now the z value for here, for the 45% area from here to here, from here that the occupy the 45% area approximately, so that this z will be now 1.6 plus 0.05, means what is 1.65, this z value. okay, this is the z value. So if we find this z, then what will be this x test? So now we will find the 90% interval in with, so x test, now x double test is 1.65 and x test similarly it will be 40%. in this the same thing, because this is a symmetric graph, so this area will be minus z test, means x test will be minus 1.65. okay, so now easily we can, from this curve easily we can conclude that on the range minus 1.65, means on that range minus 1.65 to 1.65, on that range our mean will lie on 90% confidence, will lie on 90% by simply using. If you're interested, just I'm taking here the 90% area examples, but if you're interested, you can easily find the 95% anything. First you have to divide these things, then find the range on that using these tables. Okay, in previous day, in pre-computer days, the scientists, the engineers, the mathematicians are using these tables to find the confidence levels of their estimations. Okay, but in today's we have huge complexity, huge computational power. We can easily find this value by our computers. Okay, I think you got understand how these things, how the confidence interval actually computed using these tables. I think you will got the idea how these things are, how these tables are actually work on these examples. Easily from here, easily we can find the 80% area. So if you just taken the interval on that 80% confidence level, then what should be the value? So the if 90% in this range, it will be 90%. So I think in general common sense, this range will be increased. Now let's see where the 40, where the 40. Now let's try to find here what which be the 40, means what is 40. Let's try to find the regions of the 40, like here the 40% means the 40% here means 1.2, 1.2 and 0.9, means in the regions of minus 1.29 to 1.29, in that region our mean lie on 80% confidence, lie on 80%, 80% confidence. This is the common sense, because if we just close the area, if you just smallerize the area, closing the area, this means what? This means we are much closer to our means, we are closing to our area. That means we have reduced our confidence levels. Okay, if you taking the more data of our distributions, that much we are confident our population mean like on that. This is the common sense. Just say these things. If you close the area, means our confidence are much reduces to take our population mean. If you just take the huge amount of data, so that the number of the size of the data are depends on the confidence. So size of the data increase means our confidence levels is increased, and size of the data are reduces means our confidence levels are decreased. That's the thing we have to remember. So I think you got the idea how using these standard normal tables, how easily we can find the confidence levels for any distribution. Means just I am giving here the examples as the normal distributions. You can easily find any distributions by using this kind of table, using simple this kind of.